Seeking all real solutions to this quadratic looking expression that's actually a disguised quartic. Notice the very first term, I'll just write down the first term of the corresponding equivalent quartic equation, that's a fourth degree equation, would be 567x raised to the fourth power. Okay, and that's not too hard to see. If you multiply through by this denominator, 63 times 9, in other words, this term right here is the same as 63 times 9. 9 times 63 is 567. Okay. Now I'm not going to write all the terms of the quartic, but there would be a lot of other terms. Okay, and then you could use something called the rational zero theorem. Okay. But the rational zero theorem depends on the constant in the polynomial and also the leading coefficient, which you can see is 567 with plenty of divisors. So that's not the way to approach this problem. And again, this 9 times 63 comes from the fact that 3x quantity squared is 9x squared. When you multiply 9x squared times 63x squared, you get 567x to the fourth, leading to the quartic. Okay. Now a better approach is just to observe that the denominator right here is actually a multiple of the left-hand side. When you note that 3x plus 2 quantity squared, I'll write that down. 3x plus 2 quantity squared by the binomial expansion result that we're all familiar with. 3x plus 2 quantity squared is equal to 9x squared plus 12x. Plus 4. Okay, and that's how you can tell if again, 7 times this object right here is this object. 7 times 9 is 63, 7 times 12 is 84, and 7 times 4 is 28. Now, so our original equation actually becomes something quite easy to manage, all right? We simply replace the equivalent equation, the original equation with what it's equal to. Now, a nice thing happens here. What we can do, of course, 4375, and that's not real clear, but 4375 divided by 7 is just some arithmetic is 625. Then you can actually take the square roots. Remember, we're just looking for the real solutions, not worried about complex solutions. So if you take the square roots of both sides, you end up with this object right here. Okay, now that's actually quite easy to work with. I won't show every last step of the algebra here, but if you find a common denominator, you end up with 9x squared. 9x squared plus 12x again, what I'm doing, I'm just bringing this term to the other side, finding a common denominator, and leaving out one step here. Okay, and you guys may want to verify that I did it right, but again, this is the result of finding the common denominator. Now, also the very next step, if you divide everything by 3, obtaining an equivalent equation, you will end up with 3x plus 7 times x minus 1 over 3x plus 2 equals to 0. And by inspection here, you can see that the two solutions are x equal to minus 7/3 and x equals 1. That does it. Those are the two real solutions. Both of them are rational numbers, but x equal minus 7/3, x equals 1 are the solutions to the original. Let me write that down up here for you if you want. So the solutions would be x equal minus 7/3 And again, much easier than trying to solve the corresponding quartic. Anyway, nice little solution there. Hope you guys enjoyed.